part of chapter 4 because we got a bunch of worksheets due in Shobi that are coming due probably Tuesday. We got, if we go to Shobi, always check with Shobi on when things are due. You're expected to be doing them and putting them on there. That's 15% of your grade in this class. You throw away 15%, you're throwing away, and if you don't do the math lab, that's 30%, you're not going to pass. Let's see. This is making me sign in. I just want to show you. So if it go down, and there's the marble worksheet, it was due today at 12 o'clock. I did half of the marble worksheet last time in class for you, so that should be there. Bead activities. The bead activity, I don't think I'm going to assign bead activity 2. Sometimes if you want to do bead activity 2, for extra credit, you got to use these numbers, and you do just use these numbers, and it's going to be extra credit. So it's the extra credit. Bead activity 2 is due Tuesday, February 20th, at the beginning of class. So that's an extra credit thing that you can do. Bead activity 2. Post it there. We did bead activity 1 in class, and it can't be made up if you missed Tuesday's class. But here's what's coming due Tuesday. Contingency table worksheet 2 and OWL worksheet. The OWL worksheet is just like what we're doing now, and the contingency table is the next page. So this is putting it all together. We have a picture. These are some snowmen, and some of them have hats, some of them have scarves, and some of them have buttons, buttons on them. Okay, so first off, you should count how many snowmen there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are a total of 18 snowmen. There's a total of 18, and you might want to count how many have hats, how many have scarves, yeah. Buttons and buttons, okay. So if you want to count those up first to get those numbers. How many are wearing hats? 1, 2, 3, 4, 5, 6, 7. How many are wearing scarves? 1, 2, 3, 4, 5, 6, 7, 8. How many have buttons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we'll be using those numbers later. Okay. That's probably a good idea. So what's the probability that a randomly selected snowman is wearing a hat? So we're going to let H, capital H, mean they're wearing a hat. So our probability notation is, I'll use a darker pen, is probability of hat. P of H means probability wearing a hat. Did it say that we're given something? Are we restricted to anything? No. Now I did ask you, and I posted in Shobi, I asked you to help you, this is to help you, it's a participation grade, to go into Nearpod and do the intro to multiplication rule. It will help you with these conditional probabilities. It's listed here under class discussion. So you need to do that if you didn't. Probability of H. So it doesn't say given anything, so we're selecting out of the total of 18 snowmen. And how many are wearing a hat? Out of the 7. And if we want a reduced fraction, that's it. Okay? So probability, this is, we know the sample space, we've got a picture of the sample space, so this is the number that we're wearing a hat out of the total number of snowmen. What's the probability that a randomly selected snowman is wearing a scarf? Don't print while I'm lecturing, please. Okay, let's use S for scarf. Probability of scarf is, again, we're not given anything, so it's out of the 18 snowmen. How many are wearing scarves? We already counted that up. 8. Then we're going to reduce it. We can reduce it on our calculator, or we can divide each of these by 2. We get 4/9. So that's the notation for probability of scarf, and that's the answer. What's the probability that a randomly selected snowman is wearing a hat or a scarf? This is the notation, probability of H or S. Write out the word or, don't put a plus sign or a and sign there or something. And now you have to ask, when you're doing or, are they mutually exclusive? Or disjoint. I'll just write disjoint down, okay? It means the same thing. Are they disjoint? Can they occur together? Are there snowmen that have hats and scarves on?
Yes.
Yes, they can occur together, so they're not disjoint. So we have to use the general addition rule, which will be probability of hat plus probability of scarf minus the probability that they occur together, hat and scarf. This is an intersection here. That we're just picking one snowman, so this is an intersection. So we can, let's write the probability of hat and scarf down. Don't reduce it. We've got them here. It's 7/18 plus 8/18. Now we have to subtract off because we added the guys that had a hat and a scarf on. We added them twice. So we got to look back and see how many of these snowmen have a hat and a scarf on. You see them? They're the bolder ones, right? 1, 2, 3. There's 3 that have a hat and a scarf. So we have to subtract off 3 out of 18. We added these 3 with these 7 that are wearing hats, and we added the 3 with the 8 that were wearing scarves. So we had to subtract it off. 15 minus 3 is 12, and that's over 18. You can reduce it in the calculator if you need to do that, or let's just do it that way right now. 12 divided by 18. Math, enter, enter is how you can reduce fractions in your calculator, and I'll let you use the calculator on all the tests. It's 2/3, reduces to 2/3. Okay, any questions? It's going to seem easy when I do it, and then you're going to sit there and try to do it at home, and you're going to go, this makes no sense. This makes no sense at all. So if you don't understand something, please ask, but it may take, but that's why I have you work on it at home, or you can go to the Learning Center to work on it. But if you don't do this extra work, you're not going to get it. It makes perfect sense when I'm up here lecturing, but then when you go to do it in math lab, you're not sure what's going on. So what's the probability that a selected snowman is wearing a hat and a scarf? What's the probability of a hat? And then write out the word and. Don't write plus sign there. Now, we're just picking one snowman randomly. So this, again, is an intersection. And we already found this probability. We used it in the last computation. So, how many snowmen are wearing a hat and a scarf? 3. And did it say given anything? It didn't say that we're restricted to anything. So we're picking. Don't assume we're only picking from the ones wearing hats or the ones wearing scarves. It didn't say that. So unless it says given something, we're picking from all 18. So it's 3 over 18. A lot of times people will want to write this as 3 over the number of hats, 3/7 or 3/8 for scarves. But it doesn't say given, so it's the total. And this reduces to 1/6. Okay? All right? And then what's the probability a randomly selected snowman is wearing a scarf? So this is probability of scarf given they have buttons. We're going to use B for buttons. Okay, when we're given something, that means we're only picking from the snowmen that have buttons. So we're restricted to the snowmen that have buttons. And how many snowmen had buttons? 14. So we're going to be dividing by 14. When we say given, this is the only time we change that denominator, when it says given. That's the only time we change the denominator. Only time to change the bottom of the fraction. I'm saying denominators. That's the bottom of the fraction, is when it's given. And we do change it then. So now we gotta pretend, we gotta look at the picture again, and we don't use the scarf number 8 up here unless it happens that the ones that didn't have buttons also didn't have scarves, which is actually the case here, okay? Everybody had buttons except the Frosties. And Frosty wasn't wearing the scarf. So we actually do have 8 scarves. Every snowman that had a scarf also had buttons. So we do use the 8, but if Frosty was wearing a scarf, that's the only reason. This is the intersection. We do have 8 because the 4 snowmen we got rid of weren't wearing scarves. So this would be the intersection of scarf and buttons. And that happened to be our total number of scarves, and then we reduce it. And I ran out of room to write the answer, so but that's 4/7. Okay. Is this big enough? I don't know if you can see. You gotta tell me if you can't see.
What is the bottom of the
Oh, that means the word given.
Oh,
When you see this bar, that means given. It's a vertical bar, and that means the word, when I read it, I say probability of scarf given buttons. So we know in advance, that means we know in advance we're only picking from the buttons. So snowmen with buttons. And there were 14. And then you look at the intersection of scarves and buttons for the top number. It changes the bottom number by the total over here, just whatever was given. We were given that we had 14 snowmen. We were only picking from the snowmen that had buttons, and there were 14 of those. That's whatever's here is where we get this bottom number from. So we only had 14 that had buttons, and so that's where we got that denominator from. And then the top is the intersection of scarves and buttons. And it just so happened to be the total number of snowmen that had scarves. Okay. But we would have crossed out the Frosties. Here I've crossed out my Frosties in this picture for this example. Pretend like they're not here, and you got to count up the scarves over buttons, and there's still 8. Okay, next one, probability that 3, now we're picking multiple snowmen. We're picking 3 snowmen. That's multiple snowmen, means we multiply. Up here, and meant intersection because we're picking 1. When we're picking multiple, it means we're going to multiply. So write that down. Picking multiple snowmen means we're going to multiply. So what's the probability that 3 randomly selected snowmen are wearing hats? So we write this like this. Probability of hat on the first pick, and hat on the second pick, and hat on the third pick. And assume this is without replacement, means we're not going to pick, once we pick a snowman, he's out, and we're only picking from the rest. Now, did it say we were restricting? Were we given anything? No. So each of these fractions will have an 18 in the denominator. This is going to be multiplying. No, they won't have 18. Sorry, it's without replacements. Okay, so before we pick, before our first pick, we find the probability of picking a snowman with a hat. How many snowmen originally had hats? 7. So the first probability is 7 over 18 for our first pick. That's before we pick something. The second one, now we've left that snowman out. How many snowmen are we picking from? 17, because it's without replacement. And now you have to assume that you picked a snowman with a hat. Otherwise this would never be true. So you have to go down by a number here, 2. And we could go up and cross out a guy with a hat. You know. So it's set because it's without replacement. You do your first pick. They're all there. There were 7 snowmen with hats. Then you assume you picked a snowman with a hat. He's out because we're not replacing. We're not going to pick him again. There's 17 total snowmen now and only 6 with hats. And then on the third pick, you got to assume these 2 snowmen are out and they're wearing hats, so there's only 5 snowmen wearing hats out of 16. And that's because it's without replacement. If it was with replacement, it would be 7/18 times 7/18 times 7/18. with replacement. Without replacement, and because we're picking the same thing, each number goes down by 1. And that's why we don't reduce these fractions when we write them down. Because if you reduce some fractions, you get all messed up. Just leave the fractions unreduced. These didn't reduce, but you leave them like that, and then you'll put them in your calculator. If you were to multiply through it out, you would take all the tops times each other, all the bottoms times each other, but then you'd have to reduce the fractions. But you can do this in your calculator as 7 divided by 18 times 6 divided by 17 times 5 divided by 16. And then you can press math to fraction, enter, enter. And it reduces to 35 over 8/16. So you could have divided the 6 into that, and that's probably what it would have been. Yeah. We could have done that by hand. 6 divided by 6 is 1, and 18 divided by 6 is 3. And if you multiply 7 times 1 times 5, you get 35. And I'm sure if you multiply 3 times 17 times 16, you get 8/16. But so if you want to do it by hand, you can, or you can use your calculator to reduce. And sometimes the calculator won't reduce for you. In that case, you just have to multiply through all the numerators times each other and all the denominators. But, or you can give me a decimal. Any questions? Okay, what's the probability that a randomly selected snowman is wearing a hat given he's wearing a scarf? So, this is probability of a hat, the vertical line meaning given, he's wearing a scarf. This restricts us. We get the bottom number from the number that are wearing a scarf. How many were wearing scarves? 8. That's where we get that. Whatever we're given, that vertical line means given, so the letter after that, it says given. We're restricted just to the snowmen wearing scarves. Now this top number is going to be the intersection of hats and scarves. Okay, the intersection of hats and scarves and how many. So, we're restricted up here in this last one, this second to last one. We're restricted to the snowmen that are wearing scarves, so I'll circle them. This one, this one, this one, this one, this one, this one, and this one, and that one. Those are all the ones wearing scarves. Oh, let's make it smaller. So we're only picking from these. Now we want the intersection, or we want how many are wearing scarves and hats. That's the 3 bold ones. So that's 3. So that's the only time you change the denominator is when you're given something, and then you're only picking, in advance, you're picking from those 8 snowmen. And then you want to know how many of those 8 snowmen are wearing hats. Just 3. So in that case, you didn't put 7, because we weren't picking from the other 4. Okay? 3, 8. And then the last one, find the probability. Is this going to be the same answer? Let's find the probability that the snowman is wearing a scarf given he's wearing a hat. is this the same? Are we gonna get 3/8? Now it's not the same, unless the numbers happen to be the same, but it's not. Now we have to, we're only picking from the snowmen that are wearing hats. So you put the total number that are wearing hats here, and that's 7. But the top of this fraction is the same. It's the probability of scarves and hat, or hat and scarf. That's still 3. Write it either way. We would only be picking for the snowmen that have hats on now, and there were 7 of those, and then the ones that are wearing a hat and a scarf go in the top of the fraction. Okay, so that's conditional probabilities. It's if it's multiple snowmen, we multiply, multiple picks, we multiply. And selecting 3 that are wearing hats means hat and hat and hat. And these ands up here, we were only picking 1 snowman, so those are intersections. Okay, any questions? You're gonna have to practice. Okay, the next one. The contingency table. So we have to go through the contingency table, and then we'll do the back of your warm-up after we do the contingency table. We'll do that apple thing, if you already figured it out. So we'll figure out if you got it. Okay, so here's a survey was taken at the local elementary school regarding which physical education activity was preferred. So these are the numbers that preferred tug of war. We're going to use a T for that, D for dodgeball, J for jump rope, and F for freeze tag. And then I'm just going to write first. I'm going to use a K for kindergarten and first, second, third, fourth, and fifth when I do my notation. Okay? So these are the total. If you have a chart like this in Math Lab and it's not totaled, you have to total up your columns and your rows, and this is the total number in the survey. And sometimes people try to double this. This is just the total of the columns, which is the same as the total of the rows. Don't make it 424. Don't double it. Okay, and so unless we're given something, we'll be dividing by 212. So what's the probability that a student selected at random prefers dodgeball? So probability of dodgeball, we can find probabilities from charts too, is, it didn't say given, so we're choosing from the 212 student. And it didn't say that they prefer dodgeball and they're a kindergartner. No, it said that they prefer dodgeball, any grade. You look at the total for dodgeball, that's 45. Let's see, next page. And if I ask for a decimal to 3 places, you're just going to put that in your calculator. We'll do 3 places of decimals. 45 divided by 212. And that would be approximately 0.212. And that is not because the denominator was 212. That just happens to be how it came out. That looks weird, but... Sure.
So, I know on the last page we didn't put it in decimals, so is this like just like why are we putting?
Oh, okay, if the directions say to put them in decimals.
Okay.
So I'm kind of pretending like it says give answers to 3 decimal places.
So.
If it says give it as a decimal to 3 decimal places, you will do what I'm doing here. If it says a reduced fraction, so these didn't have, oh, this one didn't tell you. The worksheets will tell you. So I pretended like this said reduced fraction. Give answers as a reduced fraction. Okay, the snowman. So just to give you an idea of the difference, sometimes I'll ask for a reduced fraction, sometimes decimal with 3 places. So, and you're right, there's nothing that said that. So, right. So, do we want to take a break, guys? We just started this, but it's been an hour already. I can't believe it. Let's take a 5-minute break. I'll pause this. Okay, so this is a neat app. It's going to make it really easy to put your stuff in Adobe. It's available it's called Genius Scan, and a free app is fine. And what it does is it works on any kind of phone. It works on, and what you do is you put your paper down, and it has to see the edges of the paper, and you tell it you have a single document or multiple, and it will take the best picture. It will be blurry, and then you'll do the next paper and hold it multiple, and it makes a nice small PDF document that you can then put in Adobe if you want. Then it'll be multiple pages, free. It's called Genius Scan PDF Scanner. You're gonna give it a shot. All right. Oh, good. Yeah. It just has to see the edges of the paper. And it's going to take a picture. You download it too? Wow. Okay. It's dark. That's all. Okay. I think we'll have some sunshine ever again. Okay, so does everybody see this great app here? Genius Scan. No, that's fine. Oh, maybe, did you print that?
I didn't print that one out.
Oh, I don't know. Somebody could use it. Who wants? All right, I'm sticking it up here. Somebody else print it. Okay, we're back. We're going to finish up this, and then we're going to do the wormy apple warm-up, and then we're done for today. We'll be doing chapter 5 Monday and Tuesday and Thursday next week, and a review for the test the following Tuesday, and a test Thursday before spring break. So you should be working in your math lab. We'll finish chapter 4 today. Don't forget to do the D2L quiz 4B. Do the survey, self-evaluation after test 1, or exam 1, whatever it says in D2L. It's a survey. And I don't remember when I cut it off, maybe Friday night. It's just a survey, so ignore the grade. I think it's a 10 out of 10 if everybody's taking it. So don't forget these silly little grades. It's just because I have your grades so far posted in D2L, and your classwork grade and your math lab grade so far. All in D2L, so look at that. All right, it's under grades in D2L. All right, so what's the probability that a student selected at random is in first grade? So probability of first grade is, again, it's nothing given, so we're going to divide by the 212. And it didn't say a first grader that preferred tug of war. No, it just said a first grader. So you got to go to the total first graders, 35 and you put that there. And if I wanted to decimal the 3 places, you would simply type in 35 divided by 212. Just look at the directions on the worksheet. And what I want, 0.165. Okay, what's the probability that a student selected at random prefers tug of war or jumping rope? Probability of tug of war or J for jumping rope. Now, anytime you do or, you have to ask, are they disjoint? And it's easier for me to write disjoint than mutually exclusive, so that's why I always say that. Are they disjoint? Can they occur together? Well, look at their 2 rows, their 2 columns, so they can't occur together. Tug of war and jumping rope don't occur together. So they had to, these students had to tell them their favorite activity, not 2 activities. So this is, they're 2 columns. Whenever they're 2 columns or 2 rows, they're going to be disjoint in the table. So it doesn't say, though, that we're picking, it doesn't say given, that we're picking just from the tug of war or jumping rope. So we're picking from the 212, and you just add these numbers together. Tug of war, the total that preferred tug of war was 46, plus jumping rope, there were 50. Then you can write it like that instead, and that is 96 over 212. So if I wanted it as a fraction, you could reduce that in the calculator, but if I want it as a decimal, there's no reason you need to reduce that. You just put it in and give me 0.5453. Okay, the talking is disturbing the rest of the class, guys. Disturbing the rest of the class, and they're trying to learn this. Find the probability that a student selected at random prefers tug of war. Probability of tug of war given they're in 3rd grade. This restricts us to the 3rd graders. So this is when we change it. Given 3rd grade. Here's the line for given. And so 3rd graders, you have to divide by the total 3rd graders. So look at the 3rd graders. The total 3rd graders are 38. And now we're only picking from this row. So we could cover everything else up, you know. And so now we want tug of war and 3rd grade on the top. That's these 13. So that's how you do a contingency table when you're given something. It restricts us to that row or column, and that's where you get to the bottom number. Then the top of it is going to be the intersection, which is just because we're only looking at the 3rd graders. It's the intersection of tug of war and 3rd graders. Okay? 13 over 38 is 0.342. And that's approximately 0.342. Okay, what's the probability that a student selected at random is in 3rd grade given they prefer tug of war? And sometimes people think this is the same as that, and it's not. Now we're restricted to the tug of war column. And how many prefer tug of war? 46. But the top number does stay the same. That's the intersection of tug of war and 3rd grade. So that's 13. So the top number stays the same, but the bottom number changes. 13 divided by 46. 0.283. Okay. What's the probability that a student selected at random is in 4th grade and prefers freeze tag? So that's probability, and you need to write the notation down. 4th grade and F for freeze tag. And we're only picking one student, so this is an intersection. If we're picking one, it's an intersection. And did it say given? It didn't say given, so we're picking from the 212. Then we look at the intersection of 4th grade and freeze tag. So 4th grade and freeze tag intersection is 7 right here. Freeze tag, 4th grade. 7. So don't try to multiply because we don't know if those are independent. Not multiplying there. So 7 divided by 212 is 0.033. So a lot of people will try to multiply and make it a lot harder. If you're picking one student, it's 1, not multiple. It's an intersection. Okay, let's get rid of the calculator. What's the probability that a student selected at random is in the 4th grade or prefers freeze tag? So the notation is probability 4th grade or freeze tag. Again, are these disjoint? You have to ask, anytime you do an or, are they disjoint? Well, we just found that they can occur together 7 out of 212 times. So they're not disjoint. They can occur together. It's a row and a column, and the answer in the middle where they intersected wasn't 0. So are they disjoint? So they're not. So you use the whole addition rule. Probability of 4th plus probability of freeze tag minus the probability that they occur together. We already found that one. It's 7 out of 212. Probability of 4th grade, as you look, that's going to be, they're all out of 212. We're not given anything. Probability of 4th, you look at the 4th grade row and the total is 38. Probability of freeze tag, you look at the freeze tag column and the total is 71. Now you just do this in your calculator. When you're adding and subtracting fractions, you have to have a like denominator. That's why we didn't reduce any of these things. And you add and subtract the numerators and keep the denominator. So this is going to be 38 plus 71 minus 7 is 102. And then we'll divide by 212. Is 0.481. Okay. And 2 more examples, and then we'll have time to do your little worksheet. And you do need to finish it before you leave class today so I can give you credit for doing it. What is the probability that 2 students selected at random are in kindergarten? So that's probability of kindergarten on the first pick and kindergarten on the second pick. And that's multiple students means multiply. So, does it say with or without replacement? If it doesn't say without replacement, you have to assume without replacement. If it doesn't say with replacement, you assume it's without. So, unless it says with replacement, it's without. And you can just do the fractions. How many, it didn't say given, so it's going to be out of the 212 at first. Before we pick the first kindergartner, how many kindergartners are there? 29. That's the first fraction. Now we've picked a kindergartner, they're out of the picks, so that's 211 and 28. And we do that on the calculator, and I'm not sure if this will work, it may be too big. So 28 times 29, I'm just going to write this down, is 8, 12, and 212 times 211. Whoops. Oh, that's all right. Is 423. No. What? Plus. No. We have to multiply, not add there. Times. It's 44,732. That's not reduced. 812 divided by, but we don't really have to reduce it, but divided by 44,732. And if I do math enter, this is just too big, it didn't do it for me, but it's okay to give me 3 decimal places if that happens. 18.018. This one didn't reduce. It does reduce because you see you can divide a 2 out of this, and you can divide a 2 out of that. It's 106. And then you can divide another 2 out. We could have reduced it by hand, but the calculator's not going to reduce it for us. The last one, what's the probability that a student selected at random is in 5th grade, given that they prefer dodgeball? That restricts us to the total that prefer dodgeball. That's 45. And then how many 5th graders prefer dodgeball? 5th grade and dodgeball is 14. 14 over 45, if you do that in the calculator, is approximately 0.311. Okay, and so we're on the warm-up, and I can walk around and help you. Before you leave, make sure I see that you've got it done and understand it. I should probably tell you this. If our picking a word, okay, so you have to add these numbers up. So there's 9, 5, 8, and 6, so the grand total is 14, not 28. And if you're selecting one at random, are the events picking a worm and picking an apple independent? And you can tell if they're independent if probability of picking a worm given it's an apple doesn't depend on picking that we know we picked an apple at all. If it's equal to probability of apple, then we know it's independent. And you're going to find the probability of worm given apple up here, and you're going to find probability that it has a worm here, and you will compare those two numbers, and if they're equal, you'll say they're independent. If not, you'll say they're not independent. So this is a question number 3 about independence. And so I'm going to stop the thing and I'll walk around